It all begins in the forging department of the Beta plant in Sulmona, Abruzzo. After over 70 years of research and experience, the steel selected for the wrenches has one-of-a-kind characteristics. When the raw material arrives, it undergoes dimensional, chemical, and metallographic analyses. The steel bars are cut into sections. The pieces are cleaned in a sandblaster to remove all steel impurities, which could enter the metal during the following stages. The forging department of Sulmona provides heating, hot rolling, and hammer molding. Loaded into an automatic elevator, the pieces of steel enter one by one into an induction furnace, which heats them to 1,250 degrees centigrade. The originally tough and resistant pieces become ductile and malleable, and therefore they can now take the desired shape. The hot rolling mill will give each piece an elongated shape, with areas having different diameters, in order to obtain the exact quantity of metal needed to form the wrench. A nitrogen atmosphere protects the purity of the steel from the surrounding oxygen, which would cause burns and slags. The hot rolling mill directs the pre-shaped pieces into an impact machine, the hammer. The power of the hammer heavily compresses the hot material between two molds, in which the shape to be obtained is then formed. The molds are always kept at a constant temperature in order to avoid thermal shock breaking and to guarantee their accuracy. High levels of concentration, sensibility, and dexterity, which are synonymous with years of experience, are a must to correctly align and position the hot-rolled pieces with the molds and manage the hammer. When a new product is introduced, Beta's engineers at Savico translate ideas into designs, realize the three-dimensional model of a tool, and generate commands that allow the machines to build the necessary equipment. A high-speed milling machine shapes the molds and regenerates the worn ones. The frequent dimensional control of the forged pieces allows in the molding phase to determine an immediate replacement of the worn-out molds in order to ensure maximum accuracy. After a slow cooling period, the next operation takes place. The correct dimensions of the forged pieces are carefully verified. The burrs and exceeding material generated by the hammer in the forging phase are eliminated. The shape of the finished Beta wrench, known as item 42, is now definitive. Another dimensional test then follows. After an additional surface cleaning, the rough wrenches are sent to the Savico plant to complete following phases. Here, the wrenches are ground. Once this was done manually. For years, robots, through abrasive belts, have performed the correction of the external profile to eliminate the roughness generated by the blanking, thus smoothing the surface. The technical and tooling departments constantly study and create ever more innovative systems, as well as ensuring the maximum efficiency of all the machines in all the Beta plants. Thus, this has changed from manual loading to a fully automated process. However, human expertise will control that the tools are in full compliance with standards. Tumbling makes the surfaces that come into contact with the hand pleasant and ergonomic. Porphyry stone, water, and abrasives slowly rotating smooth all surfaces. In fact, after this treatment in tumbling barrels, the piece is called tumbled. A hydraulic press with special minted imprints embosses the trademark and size. A multi-spindle drill creates accurate bores on the ring end. The mechanical department controls that the operating ends are in full compliance with the tolerances for correct future matching of the tool to the nut. A shaped tool called broach is inserted into the bore and pulled down, generating the bi-hex profile of the tool. The process of the open end is similar, using an external broach. Special gauges are used to control the product and the dimensional tolerances related to it. Once again, fire is the key player of the thermal treatment. In the previous phases, fire has made steel malleable and workable. Now it's going to confer hardness, strength, and toughness. The wrenches, well displayed in metal baskets, enter the hardening furnace until reaching a temperature of 850 degrees centigrade. The dissociated methane at a high temperature generates a gas that protects the pieces from oxidation. The dissociated methane and the hardening phase give the metal strength and durability. The wrenches are then quickly dipped in an oil bath. They cool rapidly and become very hard and resistant, but not sufficiently elastic. After a thorough washing phase, the wrenches are once again heated to 360 degrees in the tempering furnace, and after a slow cooling to 180 degrees centigrade, they become tough, thus resistant to shocks and stresses. Now the structural transformation of the steel is over. Raw material and hardening are the main quality ingredients of a wrench. The control of the final structure of the steel is crucial and is done before the final phases. This will improve the aesthetics and resistance to impact and corrosion. In large vibrators, the combined action of chemical additives and small ceramic stones perfectly polish all surfaces of the tools, which are magnetically separated from the stones. Now the wrenches are ready for the finishing phase. During galvanic treatment with an electrolytic process, a thin layer of material is deposited to add qualities to the wrench that are lacking in the steel. In particular, nickel and chrome improve aesthetics and render the tool resistant to corrosion, atmospheric agents, and aggressive substances with which the tool will enter into contact during its long life. A thorough visual control shows any aesthetic imperfections. Before the wrench is ready to be sold, there are still several tests to be performed. The hardness must always be greater than the ISO specifications. The micro hardness tester also checks the decarburization, i.e. that the hardening and tempering phase has not removed too much carbon. The thickness of the nickel plating must also be uniform and of the correct size. The hardest conditions of use are simulated in the quality control department. The wrench undergoes torsion tests that overcome even those required by the current standards. Static torsion test and dynamic torsion tests. Corrosion resistance is tested by dipping the wrench in a saline atmosphere. A further final test verifies that each batch of wrenches comply to the better standards, which have always been higher than those required by the international standards. Now the combination wrench can be packed and stocked in Better's warehouse. After 10 controls and a total of 24 phases, combination wrench item 42 Better is ready to be sold worldwide.